one for us to do. I am videoing every period, so some of it might be repeat, but other classes might ask questions that you don't ask. So if you want to watch the reviews, you certainly can look at it. Maggie? Number 5. How much will I have in my account if I deposit $1,600 at 3.1% interest compounded quarterly? Now, I don't know if you noticed or not, but the formula sheet that you got yesterday had a couple of additional formulas over to the side. Remember that? They're kind of written there. Those were your interest formulas. And this one is the one that is when we compound interest a finite number of times. So in this case, it's compounded quarterly, compounded monthly, compounded daily. This would be the formula that you would use. Now, I will give you that formula, but you will need to know that it's the right one to use. You'll need to know how to pick out the formula you use. This is the one for compounded quarterly, daily, whatever, monthly, whatever. Okay, I'm looking around the room, I see a bunch of people with no lanyards, I see a hood, I see stuff that's not school uniform. Understand that on exam day, kids, if you're not in uniform, you're not taking the exam, okay? Plain and simple. We have been directed that no senior is to take the exam if he or she is not in uniform. I'm not sending you out to get in uniform, you're simply not taking the exam, which means you either get a 0 on it or you have to come back the next week in school uniform and take it. I'm done messing with this. It's ridiculous. Get your lanyards on, get your jackets off, and get yourselves in school uniform. If I were you, I would be embarrassed. I would be embarrassed. Don't put me in that spot, because I'll do it. I'll make you come back next week or give you a 0. Okay? Get in uniform when you come in here. All right, so now, how much will I have in my account? This is the end amount, so that's what I want to know. How much will I have in my account if I deposit $1,600 at an interest rate of 3.1%? Now remember, no matter which formula you're using, when you put in the interest rate, it goes in as a decimal, so 0.031. I am compounding quarterly, so that's 4 times a year, and I'm doing it for 25 years, so my exponent will actually be 100. 4 times 25. Somewhere in your notes, we went through what all these different letters mean. I've now plugged them in so you can see. But remember, we're reviewing today. You already know all this, so go back, find those notes, and look it up. Now, this I just typed into my calculator. If you type it in exactly the way I wrote it, you will be fine. 1,600 parentheses, 1 plus 0.031 divided by 4, close parentheses, raised to the 100th power. You should get $3,462.59. Compound interest formula, right there it is. If you want to, type things in 1 at a time or whatever you can, just make sure that's the answer you get. Okay, yesterday's quest, which we'll get back on Monday, I had to take off, because of the bonuses, it didn't look so bad, but I had to take off quite a few points because people weren't typing it in correctly. Make sure you're typing it in and get the same answer I did. Then you know how to type it in. Okay. Are you looking for a review sheet, Tayshawn?
Yes.
Okay, they're not back there.
You got how many ones?
All right. Who else found one to work on? 6. How many radians is 500 degrees? on some problems that we did yesterday, we actually had a radian measure and we changed that into degrees. This is the opposite. Does anybody remember how to change a degree into a radian? Camel.
Put pi over 180.
Yep.
And so that equals that extra.
Perfect. That is absolutely right. Very, very good. So we set up our little proportion. We know that pi radians is 180 degrees. This is like 1. We know those are the same. So we're trying to figure out what's the same as 500. So we cross multiply. And we have 500 pi over 180. This is a no calculator problem. Remember, they're only calculator if they're starred. So you gotta reduce this by hand, so you take out the zeros. So we have 50 over 18, which is gonna be 25 pi over 9. And that's our final answer. That's how many radians make 500 degrees. All right, who else found one? Dave?
13.
13. Oh, you have a pass? Okay. A, B, C, or D? Dave? Thank you.
All of them.
Seriously?
13 in general. I know C, you multiply A, B. Can we just go through them all?
We can, but oh my gosh, we just did this, and that first problem is, okay, A plus 2 B's. So 2 B's would look like this. That's 2 B's. Right? And then when I add them term by term. So 1, 12, 11, negative 3. That's like common sense. I mean, right? I mean, if you're stranded on a desert island, that's what you would just do.
I remember now.
Yeah. And then the determinant of C. Well, C is this one. So who remembers how to find the determinant of something like that? Yeah, this is not so common sense. This is a procedure you have to know.
Add another row.
So we take the first 2 columns. So these are the columns. Here they are, the first 2 columns, and just put them over here. And then we multiply, starting right here always. We multiply and get 0. We multiply again and get 0. And then again and get negative 2. So then we add those up. So we multiply these numbers, we multiply these numbers, we multiply these numbers, and we add all that up. Then remember, you turn around and you multiply those, and you multiply those, and you multiply those, and you add those up. Then what do we do with those 2 numbers that we got from adding everything up? We don't add them together. Oh, no. We subtract them. So it's negative 2 minus 7, which is negative 9. So the answer to the problem would just be the number negative 9. And then C is A times B. Sometimes, remember, you can't even do this. But I think I can do these because this is a 2 by 2 and this is a 2 by 2. And the rule for multiplication is those 2 numbers have to match. So to get my answer, which will be another 2 by 2, I take the first row numbers times the first column numbers. So my first row is 1 and 2, and my first column is 0 and 4. So I multiply each pair and add them up. So that'll be 8. Remember this? So then I move over and do the first row times the second column. So my first row numbers times my second column. So it looks like that's going to be a 7. And then I gotta go to my second row times my first column and my second row times my second column. So that bottom row of numbers looks like negative 20 and 10. And then A inverse. Does anybody remember anything about finding the inverse? Okay?
Don't you like live every like if it's a positive, negative?
Okay, well there's some of that going on for sure. We take these two numbers right here and we flip flop them. And then these two, you change their signs. So that becomes negative 3 and that becomes negative 2. So these two get flip flopped and these two get change their signs. All right, that's half the answer. What's the other half? Whoa, 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 whoa. Who remembers?
Cross multiply.
Well, I gotta find the determinant. So to find the determinant, I have to evaluate this determinant. And that's multiply those two, and then subtract. So it's this minus this. So that gives me negative 11. Then I take that negative 11 and divide all of these by it. So put them all over negative 11. And then if anything simplifies, I do it. So in this case, all we're gonna be able to do is get rid of some negatives. So 5 11ths, 2 11ths, 3 11ths, and maybe 1 11 would be your inverse. Sometimes the fractions reduce. Like if you're writing by 8, you might have 2 over 8 or something. And you always want to do that. You always want to reduce your final answer. For problem 14, I can't remember if this is the class or not, the cross off. The only thing in number 14 that you guys are responsible for is amplitude and period. So you don't need to worry about, we did not do phase and vertical shift, but we did do amplitude and period. So you need to know how to do that. All right, who else found something? Avery. 14. Yeah, that's, we're just finding amplitude and period. So does anybody remember anything about this?
No.
So when we did these, all we had was something like that. We didn't have all that extra stuff. The other classes do all that, but you guys didn't. You just had an equation that looked like this. That's all that matters to you. So all that plus minus stuff, you don't even worry about. That doesn't have anything to do with period and amplitude. Amplitude is this number 4. Amplitude is always positive. And so even though that's a negative, amplitude is still positive. The negative turns the picture upside down. We're not graphing, but if we were graphing, it would be upside down. Period is always 2 pi, or excuse me, not 2 pi, 360 divided by that number. So the period of this function would be 180 degrees. You can go back and find all that stuff in chapter 4 if you need to look at it. What? problem. Gonna need a calculator to do this. So it says 4 sine equals 3, and it says we're in degrees. And I'm solving for x. So what do you think's the first step? It's obvious. What's the first step gonna be? Look at that equation. What? Divide by 4. Yep, we're gonna divide by 4. No matter what kind of equation you were solving, you get rid of that coefficient, you divide by it. Now, this is where things get a little tricky. You gotta really remember a bunch of stuff. That's the downside of trigonometry. It's super simple, but there's a lot to remember. Sine is associated with which letter, X or Y? What's it rhyme with? I, Y, sine, I, Y. It's associated with Y. Sine is Y over R, okay? This is a positive number. In which quadrants is Y, sine, positive? Which quadrants have positive Y's? 1 for sure. I'll make a little triangle in quadrant 1. Where else? 2? Aren't these Y's positive? Think about points over here. Isn't there a positive Y? Now, I need to find that angle. If this was a √3 and a 2, I could do it without a calculator because that's one of my special triangles. This is not a √3 and a 2, so I need a calculator. And I am going to do second sine 3/4. That's how I find an angle. Now first I'm checking my mode, make sure I'm in degrees, and then second sine 3/4. 48.59. So one of the answers is 48.59. Quadrant 1. X is 48.59. But the other answer is this one. How will I find out how big the red angle is? Subtract from 180, that's exactly right. So 131.41. 131.41. That's a toughie. Probably one of the harder questions. You gotta remember that sine is y and y is positive up here. Second sine 3/4 gives you the angle. And then we're gonna subtract it. All right, who else has one? These are good so far, good questions so far. Who else? Hey, you were supposed to circle 10. We should not be sitting here staring at each other. 11. How many triangles are possible? What are the possible answers to this question? 0, 1, or 2. 0, 1, or 2. This exam is not multiple choice. It's like a regular test since you're taking it in a regular class period. So it's about the length of a regular test. That's what it is. So it's no multiple choice. But you can still guess 0, 1, or 2. All right, how do we tell? What do we do? Is your hand up, Keishawn? How do we start? This should be a clue right here. When you see something like that, what pops into your head? Not SOHCAHTOA. SOHCAHTOA, so, S-O-H, hypotenuse, right triangle. If you don't have a right triangle, you are not gonna SOHCAHTOA. What do we do when we don't have right triangles? So sine 79 over 15 equals sine E over 16. That's called the law of sines. And whenever you see this, you have that angle and that side, or this angle and this side, or this angle and this side, whenever you have that pair, you're gonna do the law of sines. Okay, so we cross multiply. 15 sine E equals 16 sine 79. Then we'll divide. So sine E equals 16 sine 79 over 15. Now it's kind of like this one we just did. We knew the sine was this number. Just like now, we know the sine is this number. But we don't really care about that number. We want to know the angle. We want to know what angle E is. So what do we type into our calculator? Second sine. So we're going to second sine that big fraction. If you need an angle, you always second. Sometimes it's second cosine, sometimes it's second tangent. This one, it's second sine. 16 sine 79, close parentheses, divided by 15. Oh, wait a minute. I'm gonna type that in again. Did something happen to you when you did that? What happened? What did you get?
0.4.
I got an error. Did you get an error? What does that mean? If we typed it in and got an error, what does that mean?
0.
No triangles. How many triangles are possible? 0. All right. Another question. Which one? 9B says find the area of the triangle. Now these are calculator problems. We're finding the area of the triangle.
What number?
9B. There's a handy dandy little formula for this. It's really easy. You don't need to do any work. You can just get this answered. Remember how that works? Area of a triangle?
16 over 13 and 15 something
Yeah,
else.
don't all the degrees add up to 180? You just subtract?
They do, but I don't know two of them, so there's no way to figure out what those are. I mean, I can figure out what they are using law cosines, but I don't need that information for the area. The area of the triangle is 1/2 side, sine of included angle. 1/2 side, sine. 1/2 side, sine is the area, is a way of finding the area of a triangle. So 1/2 times 16 times 13 times sine 58. The area is 88.20 square feet or whatever unit it is. Now the other area, there are two area problems. I won't do the first problem. I won't do letter A this way because why? Why can't I just do the same thing with letter A? There's no angle. So does anybody happen to remember what we do when there's no angle? add them all up, so in other words, we find the perimeter, and this perimeter would be what? 36? And then we find the semi-perimeter, which is half of that, so that will be 18. And then we make a big radical, and 4 numbers go in the radical, and the first one is the 18. Anybody remember where the other 3 numbers come from? They aren't the sides. Do not put the sides in there. Now, the sides are involved.
Aren't they like half of the size?
No, it's not half the side. It's this number minus the side. So 18 minus 15, 18 minus 10, and 18 minus 11. So where did the 18 come from? Half the perimeter. Then the rest of those numbers were that number, 18, minus each side. When we did this back in chapter 5, a bunch of you put in like 15, 11, and 10. No, it's the semi-perimeter minus each side that goes in there. Then, just type it all up, take the square root of it. And that's about 54.99. Okay, one more. Oh, yeah? 25. This is another area problem. We're finding the area of a regular octagon. So it's already drawn for you and everything, so that's good. You want to find the area of this thing, and we know that the radius is 10. Anybody remember how we did this? Campbell?
You take the radius and divide it by 360, right? Or divide it by the side.
Okay, now there's a 360 divided by something involved. If you think about it, isn't this octagon made up of 8 triangles? So the central angle here, Campbell, will be 360 divided by 8. Does that make sense? So that's 45. These are 10s. All the radii are the same, so they're all 10s. So look at that triangle. Can't I do 1/2, 10, 10, sine 45? Can I do that with this triangle? Remember, area is 1/2 side, sine of the angle in between them. So I can type that in. So 1/2 times 10 times 10 times sine 45. Now that's the area of the triangle. So what will I do to get the area of the whole octagon? Times it by 8. So the answer is 282.84. Could you do the same thing with a hexagon or a decagon or something like that? Yep. Yep, you sure could do exactly the same way. All right, back in your seats at 12:20, and we will continue reviewing.